talking about the PRU Speak project today. This is a project I've undertaken for Google Summer of Code 2014 while working with beagleboard.org. Okay, so I've logged into my beagleboard. I'll be demoing the PRU Speak project now. So CD. So let's get into the project first. So there are three main files which you would require for the first time. So one of them is install.sh that takes the binaries and installs them in the required folders of your BeagleBone Black. Another one would be environment setup, which would set up the required environment, and this is the first thing you'd be running. That's the build file, which will build all the binaries. So now, if you would see cd bin, so you will see that all the binaries have already been built, so there's no need to build them again. So now yeah, so let's run install.sh followed by msetup.sh. So now if you look at the dmessage output, you will see that the PRU speak has been loaded and it's running right now. So let's see what we can do with the PRU right now. Once we made sure that the PRU Speak has been installed, we go into the source folder, then the user space slip folder, where exist three interfaces of our interest. So first one is the FIFO that enables you to use PRU Speak as an extension of the Linux file system. Another one is the interactive shell, which I've developed for interacting with PRU Speak. And then the other one is the TCP server, which you can stream bot speak instruction on port 6060. So now let's try a simple example. Okay, that's what I meant. So Python speak shell.py. Okay, so this is the interactive shell we have. So set dio 0, 1. Okay, as you can see, the LED has been set. Now set dio 0, 0. Yeah, the LED is off. Now we can have a script over here. So let me set var1 or var0 equals to 0 and set var1 equals 1. Okay, so we set two variables, variable 0 and 1 with values 0 and 1. Now we can so let's see that script, then set dio of 0 to 1, then wait for a second, then set dio of 0 to 0, then wait for a second. Now go back to first one, then okay, so now we have a script which can blink an LED for 1 second. Now what we do is run the script. So as you can see, the LED is switching on and off. This was the first tiny program using PRU Speak. Next we'll be having a look at PWM and other more complex examples. Using PRU Speak. So PWM becomes really simple. So all you have to do is set PWM 0, 0. So now yeah, there we go. So now it's the PWM output is 0. It's set PWM. Okay, so now the parameter over here can take values between 0 to 100. So let's try 50, 0. Oops, sorry, 50 comes here, my bad. this would be the channel, and we'd have 50 over here. So that's half brightness now set. Actually, it's more than half considering the LED doesn't require 100% to gain full brightness. 0, 100. So that's full brightness and set. Let's see something else. 0, 25. So it's still glowing, but it's quite less now. A more interesting program using this would be so here I've written down a program. There we go. Yeah, so it's basically creating a triangular wave. Okay, it's not 0.5 hertz. So here we have a script that we have variable 1 which goes from 0 to 100, and each time the PWM is set there with the delay of 30 milliseconds, and once it reaches 100 it goes all the way down back to 0 and then continues the whole cycle once again. So let's have a look at this. Python. So as you can see, the LED, it's slowly gaining brightness and slowly decreases again. And once it hits low, it again, so it's more or less like a heartbeat. This is a really nice and quick written program, and thanks to pruspeak you can do it in a few lines of code. So this is so much for PWM, and you've even seen constructs like if and other arithmetic constructs being used in the example code. I'll just put it up once again. Okay, so we add, we compare and jump. We also subtract. So this is quite a comprehensive example which covers a few features of pruspeak. So yeah, that's about it for PWM. So now we'll look at how the PRU Speak module takes inputs. As of now, only one pin, that's GPIO1 underscore 14, has been configured for input, and this can be accessed as follows. So if I do get DIO of 14, I get 0. So now in my circuit, which I am not showing right here, I've just connected DIO 0 to DIO 14, which is input, and DIO 0, that's output. So now if I do set DIO 0 comma 1, and now if I do get DIO 14, you see that yeah, the input is 1 right now. So basically what happens is when DIO 0 goes high, so does the input value for DIO 14, hence I read 1 back from DIO 14. So this is basically how the input works. This feature could be used for taking button inputs and other digital sort of inputs. As of now it's limited to 1 pins, but soon it will be configurable to as many pins available or exposed by the PRU. So I'm working on that right now, but this is basically how it works. So yeah, that's it.